So hi there. Today I'm gonna be talking about the Kelvin scale. It's a temperature scale. So first I'm gonna talk a bit about it, explain it, then I'm gonna show you how to convert from Celsius to other units. So if I start off with example, so if I draw a balloon, it's a funny looking balloon, but bear with me. And these are air particles inside it. So if I heated that balloon up, it would expand, so the volume would expand, so the balloon would get bigger. And that's what it does. Heating something up, it just gives a greater kinetic energy to the particles. So these white particles just act as if they're like air particles. So they'll have a greater kinetic energy. So they'll be moving around a lot more. So I'd increase the volume, like on this balloon here. So that's heating it up. So the more you heat it, the greater kinetic energy, the greater volume. And if you take out the heat or slow initially, it's the same as saying cooling it down. So if you cool it down, it gets smaller, and the particles inside, they get closer together. So a smaller volume compared to the large balloon. So this, we can graph this, and it's been done before, experiments. So if I draw a graph here, so studies show on the Celsius scale, when you do this, that's degrees Celsius, and this is volume, this is temperature, and the units are degrees Celsius. So this is the big balloon here, and it's got a greater volume with high temperature, and when you take out the heat, the temperature gets lower, so does the volume. So experiments show that when you get to a certain point, it's still possible to follow it down, even though we can't get to this really with the scientific equipment we've got at the current time. It shows that it is possible to get to a degrees below 0 degrees below, and this is known as absolute zero. And that is equal to minus 273.15 degrees. So that's how much it is in degrees. So whereas this is in Celsius degrees, this graph, you can actually go further, all the way up to minus 73.15 degrees, and you can't get colder than that. So initially at that temperature, there's no movement of the particles. So you might be thinking, maybe you can go below this, but does it really make sense scientifically, numerically? Because if you go below this, you're getting into negative volume, and there's no such thing. It doesn't make sense, does it? So to our knowledge, this is the coldest something can get. So then the different units, Kelvin, it's the same thing initially, but it's the graph moved to the left. So basically someone came along called Lord Kelvin, and they moved everything to the left. So they made 0, this part here 0, and this carried on straight line. So you can't get, there's no minus this way, because you can't get colder than that. So initially they just moved the whole graph along by 273 minus 273.15. And the way to convert between these units is, so to get Kelvin, you just get your units Celsius, the Celsius degrees, and just add 273.15 to any. So this is only to get into Kelvin from Celsius degrees. So if you had like 100 degrees and you want to turn it into Kelvin, so you just get 100 plus 273.15, and that'll be 23.15. It's as simple as that. And if you wanted to get from Fahrenheit to degrees, it would just be easier to convert from Fahrenheit to Celsius than to Kelvin. So that's about it, really. It's not that hard converting degrees to Kelvin or Kelvin from degrees. It's a matter of adding or subtracting minus 273.15, which is absolute zero. So thanks for watching. That's all.